Hi everyone, a very good evening to all. Now we are going to study about one simple question number 68. It's all about modulus of elasticity. So to understand this, the very first thing is what is stress and strain. So stress is nothing but force per unit area, and force may be perpendicular or parallel to the surface. Perpendicular means normal stress and parallel means tangential stress. So two types of stress you can define. And when you apply force and stress is developed, then there may be a change in configuration happens. So the change in configuration is called strain. So change in configuration is nothing but strain. So that is nothing but change in dimension by its initial value, like change in length by initial length, or change in volume by initial volume, or change in position by some angle. So these three types will be there in this chapter. So one is length change, delta L by L. Another one is volume change, delta V by V. Another one is position change, means the position got displaces by some angle theta. So three things will be there. Now in each case, when there is a stress corresponding strain and there is a corresponding modulus of elasticity constant will be there, and that is when you apply stress and strain develops, so that up to a limit stress is proportional to strain, and that proportionality constant is called E, that is stress by strain, that is called modulus of elasticity. Modulus of elasticity nothing but ratio of stress to strain up to certain limit that remains constant, and this proportionality limit we call it as Hooke's law. So that if there is a graph between stress and strain, then it must pass through origin up to certain limit. Then the slope of the graph is equal to modulus of elasticity. Now the next thing is how many types of modulus of elasticity are there. So when you consider a wire of length L and you apply force, then the length became suppose L plus delta L by the application of force. Then the Young's modulus is longitudinal stress by longitudinal strain, and that is F by A by delta L by L. So Y equal to FL by A delta L, or F equal to YA delta L by L, or delta L equal to FL by AY. These are the formulas. In third case, when you consider a solid sphere inside the liquid, then the pressure will apply at every point so that there is a decrease in volume. So delta V. So delta V is called decrease in volume. Then there is a constant B, that is bulk stress by bulk strain, or you can say like volume stress by volume strain, and bulk stress is nothing but pressure by minus delta V by V. Minus comes because there is a decrease in volume. And the third one, when you consider a cubical body fixed at the bottom, and when you apply a tangential force parallel to the top surface, then it will get shifted by some angle theta. That means the top edge will move by some distance delta x. If side length is L, then tan theta is approximately theta equal to delta x is by L. This is called shear strain, and in this case rigidity modulus will come, that is shear stress by shear strain, or FL by A delta x. So based on these three things, the questions can be asked based on these equations, or they can ask question based on stress and strain depending upon the question. But sometimes in case of Young's modulus, comparison based question they will ask between two wires, that is delta L1 by delta L2 equal to F1 by F2, L1 by L2, A2 by A1, Y2 by Y1. They may mention particular condition like force may be same, area may be same, or material may be same. Whatever it is, depending upon the given question, you have to consider the situation. Sometimes they will also mention volume is same. So between two wires, volume constant means A1 L1 should be equal to what? A2 L2. Like that, based on this simple formula, the question can be asked. Now, the very first thing is, a wire can be broken by applying a load of 20 kg weight. The force required to break the wire of twice the diameter is. So a wire can be broken by applying a load of 20 kg weight. So what is the weight of the mg? 20 kg means 20 into g. This is the force applied. Now the force required to break the wire of twice the diameter. So breaking stress nothing but force by area. Now force by area means here mg. Sorry. Here force is weight of the body by area. Now breaking stress depends upon area. That means breaking stress is inversely proportional to square of the radius. So now breaking stress for second one by breaking stress for first one equal to R1 by R2 whole square. Now R1 is R and R2 is twice whole square. That means 1 by 4. So that the breaking stress will become 1/4. So 5 kg weight will become the answer. Now the same breaking stress sometimes due to its own weight they can ask breaking stress equal to F by A. Now when you consider a wire, the mass of the wire M equal to volume into density. Volume means area into length into density. So force equal to due to own weight mg. M is AL rho into G by A cancel. So breaking stress will become L rho G. So what should be the length of the material so that it breaks by its own weight means the length equal to breaking stress by rho into G. And in the given question, they have given density, they have given breaking stress and G value. Everything they mentioned, you just try to substitute and solve the question. Now, here is a question based on bulk modulus. So the bulk modulus they have given as 9.1 into 10 power 8 Newton per meter square. To what depth a rubber ball be taken in a lake so that its volume is decreases by percentage change in a quantity means delta x by x into 100, that is 0.1. So that you will get volume strain as 0.1 by 100, nothing but 10 power minus 3. So bulk modulus is given, volume strain is given. So to what depth we have to take means when you take to a depth h, the increase in pressure is h rho g. So that delta P value will become B into delta V by V. So B value given, delta V by V given. H rho G if you can equate it, then H value will become B into delta V by V by rho into G. So this way you can solve the question. You can understand. But here collecting the data is important and taking the proper formula is important because 0.1% how to take it, that you should understand immediately and you have to take it properly. So that you can realize that from that given data you can find volume strain. Now the next question, the area of cross section of a steel wire Y value they have given as 2 into 10 power 11 Newton per meter square and area is 0.1 centimeter square. Now they are asking the force required to double its length. So delta L means L dash minus L, that is final length minus initial length. It should become double. So what is the change in length? Equal to initial length. So delta L by L how much? 1. That means strain is 1. Strain is unity. Then force by area, that is stress. So stress equal to Y into strain. So that force equal to Y into A into strain is 1. Y value given, area value given. Only thing you have to take care is the area units conversion. Centimeter square they have given. So you have to take it in terms of meter square. Now one last and final question. So here the question is, a wire of length 2 meter is made from 10 centimeter cube of copper. So volume they have given. And a force F is applied so that its length increases by delta L1 is 2 millimeter. Another wire of length, now another wire of length they have given 8 meter is made from same volume. So volume is same. If the same force is applied, its length will increase by delta L2 how much? Now delta L2 by delta L1 equal to, as we have taken, F2 by F1 and L2 by L1 into A1 by A2 into Y1 by Y2. Now both are copper, so Y1, Y2 cancel. Both experiencing same force, they get cancel each other. Now here L2 by L1 times A1 by A2. They have given V1, V2 and L2 value they have given. So what you do is, now L1 also they have given, L1 is 2 meter, but they have not given A1, A2. But they said that V1 equal to V2. That means A1, L1 equal to then A2, L2. Then A1 by A2, I can write it as L2 by L1. Then the equation will become delta L2 by delta L1 equal to L2 by L1 times A1 by A2, I can write it as L2 by L1 equal to L2 by L1 whole square, where L2 is 8, L1 is 2 whole square. So it will become 16. So this way delta L2 will become 16 times delta L1. So this is how the questions can be asked, simple questions based on stress or strain or Young's modulus, or comparison questions based on Young's modulus or bulk modulus, or they can also ask rigidity modulus. So just try to remember the formula, understand the question and collect the data, then try to solve it. Now this is the example questions I have given, similar kind. So please just try to solve. We'll continue in the coming session with the another question. Thank you all.